In these problems, we're working on finding the vertical asymptotes of some rational functions. And the way to look for vertical asymptotes is to figure out where the denominator is 0. The whole function blows up if the denominator is 0, and that's where on the graph you get things shooting up to positive infinity on the y-axis or dropping down to negative infinity on the y-axis. Those are where the vertical asymptotes are. So to find this, we want to find out where is the denominator 0. In this case, we've got a quadratic, so we can just set that to 0, x squared minus 7x plus 10 equals 0. And we can go ahead and solve this for its roots. In this case, it's pretty easy to factor. So we've got x plus 2 times, oops, wait a second, x minus 2 times x minus 5. That should work out. Yes, that works out. And then those are both equal to 0, so we get x equals a positive 2 and x equals a positive 5 when we solve each of those factors for x. So those are going to be our vertical asymptotes, or they should be. Let's take a look at the graph of this one. And you can see here at x equals 2, we've got a vertical asymptote, and here at x equals 5, we've got a vertical asymptote as well. So that seemed to work out. Now this next one has one slight little trick to it. So again, we're going to find the vertical asymptotes, and it looks like they did us the favor of factoring the denominator already. So you might set this equal to 0 and say, well, x equals negative 8, x equals negative 9, boom, you're done. You'd get that one wrong if you said that, though, because we need to be careful about the top, too. So we're going to go ahead and factor the top. We've got a difference of squares here. X squared minus 64 factors out to x minus 8 and x plus 8. And that is over x plus 8 times x plus 9. And as you can see, you can cancel those two, and what you get is x minus 8 over x plus 9. When you set the denominator to 0, then the one vertical asymptote is x equals negative 9. Now, this x plus 8, it's not like it doesn't exist. There is a hole in the graph, technically, where that is, but there isn't an asymptote. And if you look at the graph for this one, you can see we really only have one vertical asymptote, and it's here at negative 9. Although at negative 8, there should be a hole in the graph that wasn't shown on here. So that's a little bit of work with finding vertical asymptotes on rational functions. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.